All right, so for a typical car, approximately 65% of the energy in the fuel is radiated away as heat. 13% is the output as work in moving the car, and 10% is spent overcoming friction. 7% is spent idling rather than moving, keeping the engine running. The engine's a gasoline engine. And then 5% runs the accessories like the radio, lights, temperature control, and stuff like that. What is the efficiency of a typical car? And so they threw in a lot of numbers at you, and there's really no easy way to know this. But the main thing that we're looking at is the output, right? Because we want to know what work is done. But work is also equal to the energy. Well, the main goal of the car is we're going to get from, I like to draw my little cars. We're going to get from point A to point B. Same car, by the way. It's just it's moving so fast. So the output is the work in moving the car. So remember that work is the force times the displacement. And so the displacement is really, there's some force that's done. We don't know what that force is, but the displacement is going to be point B minus point A. That'll have a measurement. Okay? Consequently, 13% of that, of the total energy. So the car does a bunch of energy, but the energy that's related to work is what we're interested in. So it's really only 13%. Because the whole purpose of the car is to get from point A to point B. Does that make sense? So the correct answer is 13%. All of those things are important because at some point they talk about miles per gallon, and that's an easy thing to approximate. I suppose if you want to be, if you're concerned with carbon footprints and stuff like that, you could probably try to increase the efficiency, and a lot of cars have already done this. Maybe figure out systems where you reduce the friction, figure out systems like, for example, my car, when I come to a stoplight, as soon as I stop for like a second, it shuts the engine off. And then to go, I just hit the gas pedal and then it goes. So we're not sitting there idle, burning gas and stuff like that. So, but when it comes to work and energy, 13 is the number that we're concerned with. Okay. Are there any other questions from the